this video. Which is a network access control. And, and the major purpose of network access control is to be able to secure your network and also restrict accessibility and give access to wherever access is due, and also to be able to control how users and devices access your environment. So FortiNAC is a security product that implements our policy on devices that access networks to increase the network visibility and control, and also to facilitate automated response to incidences. So when a device connects to a computer network, it's not actually permitted to access anything on the network unless it complies with network policy, which includes the antivirus protection level, system updates level, and configuration. One of the things there are three major things that Fortinet brings to the table, which are very, very important to enterprises and organizations. And one of the key aspects of it is visibility, control, and automated response. Most importantly, in this age where we have a whole lot of data traversing the system, the environments, the ecosystem, and in an environment where there are multiple products, point products, which is being implemented by maybe organizations to protect their environment, secure their assets and all that, and also in a environments whereby they are not just implementing their solutions on-prem, and they have maybe their solutions in an hybrid environment or multi-cloud, or in a very versatile environment. One of the challenges that most organizations face is visibility, ability to know everything that's on the network and be able to locate each of these devices or hosts in the environment. And it's a very, very is an important challenge that most organizations face, and that's one of the things FortiNAC addresses. The ability to locate, find, and be able to categorize each asset in your environment, to be able to see through across your ecosystem. And we'll be talking about all these three capabilities alongside, so that so in order to share the value with your network and your environment. So Fortinet brings these three capabilities needed by customers facing both IoT and multi-vendor environments, and other issues with capabilities around visibility, control, and automated response. So when we talk about visibility, Fortinet can see every device and user when it connects to your network, which provides complete visibility to what is connecting and what is connected to your network. And this visibility includes not just seeing the IP address of the connected device, but also the ability to profile the device and also identify what type of device it is, so that IT knows what is connecting to your network as well. Then the second, which is control, the control capabilities of FortiNAC. So once devices are profiled on the network on FortiNAC, FortiNAC can segment that network to restrict device access to only those assets that it needs to reach. So let's say, for example, you have an IP camera which is given access to only to the MVR server, so that it can send the video imagery for storage and display, but also is blocked from accessing the finance servers, because it doesn't really need access to that. So those are the things you want to also take control of. So this level of network segmentation also protects against hacked IoT devices or endpoints or any other devices in your environment that is searching through the network and is attacking the sensitive corporate data and information. Then the third capabilities Yeah, and final capability of FortiNAC is the automated response. So the FortiNAC continuously watches the network, and it has an extensive automation capabilities. So, so that when a triggering event is observed, FortiNAC can take an action in seconds. And in order to ensure that manual processes are being minimized in an environment where we have continuous alerts and events and incidents. Automation is one of the things you want to also inculcate in your NAC solution, so that whenever a workflow is being defined for a particular event or alert or alarm, Fortinet can take actions, maybe send like an email to the engineering department and all that about a current incident that's occurring on the network. So, talking about the workflow of FortiNAC. So, when device connects to your environment, let's say switches or your wireless access points, so FortiNAC is informed using SNMP or radius protocol and other protocols that I'm going to talk about in the next slide. FortiNAC does profiling of rogue and registered hosts on itself. Also, after that, FortiNAC runs the policy engine for the registered host and devices. Then FortiNAC sets the access using the API, SNMP, and CLI protocols. Then the connection is done. Then the stage at which control can be applied at the point of connection. When the connection is done and the user is already, Fortinet has been able to admit the users and all that, the control can now be applied at the point of connection. So, which is at the very edge of the network, while the security device integrations allow Fortinet to process the security alerts, treat them as triggers for automated threat mitigation through the customizable workflow. So, in terms of visibility, gains and understanding of the network infrastructure through the modeling of the switches, the routers, wireless controllers, and the access points. Then these infrastructure devices are organized within the user-created containers in the topology view. So in terms of deployment option, FortiNAC is a centralized architecture device, which is an out-of-band solution, meaning that it does not sit in line of the user traffic. So, and this architecture allows FortiNAC to be deployed centrally and manage remote locations as well. So, the likes of the visibility, control, and response are achieved by integrating with and leveraging the capabilities of FortiNAC to the network infrastructure. Also, in terms of data collection, data is collected and gathered from multiple sources on the network using the variety of methods like SNMP protocol, the CLI, the radius, syslog, API, and DHCP fingerprints. All these protocols can all be used to achieve a detailed end-to-end visibility necessary to create a truly secure environment. Fortinet is pretty vendor agnostic, which means that it can be integrated to um, any um, any devices, third-party devices, or vendor-specific devices within your environment. So it's not just focused on Fortinet devices. Most of the devices, most especially the routers, switches, wireless access points, and all others, and almost applications as well, are also using most of these protocols at which Fortinet integrates with in your environment. So how does Fortinet works? Once devices are connected into once Fortinet is connected to your environment, and start learning your ecosystem and the devices in your environment as well, it sees most of your devices without profiling, without anything being done, as rogue devices or unregistered devices. So we need to have device modeled. So devices are modeled on Fortinet by supplying the communication information and necessary security credentials for both SNMP version 1, version 2, and version 3, and also the SSH protocol, the likes of protocols I mentioned in the previous slide. So FortiNAC uses this information to identify the type of device that is communicating with, and then going forward to query the device for visibility information and to manage the device for control and response purpose. The ports and SSID information is also linked. So the point of connection details is known for each endpoint that connects to via the modeled device. So we have, based on the information gathered by the SNMP, the device, the type of device can be identified as well as the characteristics of that device, such as the number of ports of the switch of that switch, the administrative state of those ports, whether or not devices are currently connected to any of those ports that has been integrated with FortiNAC. So the type of device will also determine the method in which it will be managed and controlled. So talking about communicating with your infrastructure, FortiNAC's endpoint visibility is actually a live inventory of network connections that is collected through ongoing communication with the network infrastructure. So this information is the basis of FortiNAC's visibility that provides who is connecting, the details of the user that is connecting, and what device the user is using to connect to your infrastructure, and the types of connection being made, and the location of the device that is connecting to your network, where they are being connected, and the time at which they are being connected as well. These are the informations and that FortiNAC collects, and is the foundation of network security management. And because you can't actually manage what you don't see and what you don't know, so all this information about the device, about the users, the timing, the location, I mentioned earlier that once you integrate a switch to the FortiNAC, it shows the ports, both the ports, the state of the ports, each of those ports of the connecting switch and all that. So once the device is connected to any of those ports, you actually know that you are still be able to know the location of the connecting device on your dashboard. So how we achieve network visibility, the FortiNAC gathers visibility information through communication with the network infrastructure that has been established. So the methods used for network visibility data collection are how to polling, layer 2 polling, which is used to gather the physical addresses of network connected to your devices. The location information is also obtained as part of this process as well. We have the layer 3 polling as well, which is used to gather the IP address information, and it also correlates it with the physical address gathered during the L2 polling. So which adds the additional detail for the connected device, both on layer 2 and layer 3 of the connecting device and host to the network. So we also manage to see what is connecting, where the location at which the device is connecting, and when when the device connected. Those informations are collected through the ongoing communication with the network infrastructure. And this information includes the physical address, the IP address, the switch port, or the wireless SSID, and the online status of that connected device. So the network visibility is the information collected through integrations with the network infrastructure. So we have the following information that is recorded in the database device adapter records, which is the IP address, the physical address, which is the MAC address of the device. We have the vendor UI, that's the vendor, the OEM or vendor of that device, whether Cisco, Dell, or based on what's connected to your device, which identifies the manufacturer as well. Then the location. Location has to do with where the device is connected, which port, as FortiNAC highlights and layouts your switch ports on the port. So it labels it based on the labels on the switch ports. Maybe you have a switch of maybe 24 switch port switches, or 48 switch ports switches. So it labels them 1 to 48 or 1 to 24, and each location has its own specific details that is bringing to visibility of your environment. So combining the IP address and physical address with the known vendor OUI and the location, the connection times, everything brings the robust information of that endpoint into focus. So you can easily identify the device and be able to trace it whenever you want to in your environment. So FortiNAC actually also defeats MAC spoofing. So I would relay this example to illustrate how FortiNAC defeats MAC spoofing. So let's say in this example, we have a printer that is previously known to FortiNAC and that's connected to your infrastructure. The infrastructure notifies the FortiNAC of the connection of the printer. So the FortiNAC would evaluate the connected device and compares it to the list of the existing profiling rules. The profiling rules will be the ones to identify the printer and be able to tag it as a printer on FortiNAC. So if a rule is matched, in this case, which is a printer rule, then the FortiNAC will convert the unknown status or rogue status of that device, which is a printer, into a printer. Before, FortiNAC doesn't identify the device as a printer, but because of the device profiling rule that is in place, FortiNAC matches, evaluates the device with the existing profiling rule that has been defined, and with that is able to identify that this is a printer and converts the status of that device from being unknown or being a rogue device to a printer. So as you see in this upcoming session, so a network policy will be configured for the so that the FortiNAC can also provision the FortiNAC and also ensure that the printer have a level of access that is determined to have and won't have based on what it has. So once FortiNAC has the MAC address, all the informations about this FortiNAC, if a user comes up and wants to use the same MAC address that the printer has used in order to maybe spoof the MAC, maybe with his or her endpoints and all that, because FortiNAC has recognized all these details about this printer, the device that has been that wants to use the MAC address of this printer to be able to have access to your environment will be quarantined, or will be quarantined. And if you set like a notification automation for this kind of event or incidents, FortiNAC would send a notification to the SOC or NOC team so that they can see the event that is going on and all that. So FortiNAC can also be integrated with MDM services, so which is mobile device management. So the MDM services allows you to configure connection or integration between the FortiNAC and the mobile device management system. So the FortiNAC and the MDM system work together, sharing data via an API to secure the network. So FortiNAC leverages this data in the MDM database and registers hosts using that data as they connect to your network. So let's move to the control aspect of FortiNAC. In this aspect, which means that visibility has been established, and FortiNAC has seen that, okay, these are the devices based on the device profile rule, user and host profile that has been defined. It has been able to identify all these devices. So the next phase is to be able to control the device in order to place it in a category that you want. So maybe you want this device to have a level of access to maybe a server or internet or anything. So this is the place where FortiNAC, the network access policy can be implemented. So the control of connecting and connected device are now allow the network administrator to enforce strict access policies. So an environment without efficient and timely control capabilities could be at the mercy of untrusted, potentially malicious devices, which impact productivity and straining the IT resources. So FortiNAC supplies comprehensive control at the point of connection, both pre-connect and post-connect, blocking untrusted devices while granting precise access to trusted devices. So trusted devices can be continually evaluated and action can be taken if they become compromised later. So there's a consistent evaluation of devices on your environment so that when a device is compromised, despite the fact that this is even trusted, Fortinet will be able to take action at that point. So Fortinet uses access control to grant access based on user identity, device identity, and risk assessment. So this evaluation can be performed both pre-connect, ensuring proper access based on the trust level. So we have the like of the unrestricted access, restricted access, guest access, and I have no access, based on the role of a user on device. You might have your staff, the level of access that a staff or an employee will have will be different from the level of access a guest will have as well. The level of access a printer, IP cameras will have will be different from the level of access than a server in your environment will have. These are policies, dynamic network access policies that you can put in place to ensure there is a well-controlled environment. So Fortinet also supports onboarding BYOD devices, most especially, in this age, with a lot of organizations have embraced BYOD, which is bring your own device methodology, which by a user or a staff brings his device and a level of compliance is being set on that device so that the user can be able to access complaints resources and all that. And we have a couple of ways that this can be done, and this will be discussed. And so managing the onboarding of guests and employees, laptops, tablets, and smartphones can be a labor-intensive and error-prone task. So Fortinet has simplified the onboarding by streamlining the registration process. So the onboarding of guests can be delegated to a deputy onboarding administrators, and when appropriate, users can also register their own devices, shifting the workload from the IT to the end user. So the onboarding can be done in two ways. You can either do a self-registration of guests, or you can also have a sponsor for the users, so that when a guest or a contractor come into your environment and wants to have access to the network, you can set a policy. You can set a policy which is attached to the portal of Fortinet, such that the user will provide his or her information to be able to access your environment or the network that is being provisioned for them. And this information can also be used by the company as well. And also, you can also, as users are also, the guest users are being onboarded and all that, and they want to have access to maybe your the internet that you've been provisioned for them. Fortinet can redirect them to a landing page that you would provide for them. So before they can have access to whatsoever you've provisioned for them. So these are the ways where guest onboarding can be done on Fortinet. So talking about the security policy types, we have security policies is a very important aspect of Fortinet, and security policies dynamically define network access and provisioning requirements to connected devices. There are 5 different types of security policies on Fortinet. We have the first one, which is the portal, which define the captive portal page that an isolated device will be presented. This may be a location-specific guest access page, for example. So we have the authentication security policy, which define the backend authentication source for isolated hosts, such as the Active Directory, the radios, and all that. Then we have the network access as well, which provision the appropriate network access to the connected device. And this provides the ability to dynamically assign access to any type of device as it connects, such as the end stations, printers, cameras, card readers, and all that. Then we have the endpoints and compliance security policies as well, which define the security posture that must be adhered to, and the agent technology used to validate that criteria as well. So each of these policy depends on what the organization wants to define for their users and for their devices to be able to use as well. So in talking about profiles, I mentioned profiles, device profiling is very important to FortiNAC's getting enough information about your environment. So one of the things I want to do is to have device profiling set up, and there are different ways device profiling can be done in order to be able to identify the devices accurately, so that when devices are connecting to your environment, Fortinet can easily identify them and be able to tag them to the network policies that they need to be placed into. So because devices are continuously evaluated as they connect to your network by Fortinet. So if a device matches the criteria of a user or host profile, then any security policies using that user or host profile will be evaluated, and the configuration associated with the highest ranked policy by type will also be applied for that user or for that device. So based on where the user is connecting from, who the user is, what the user is connecting with, and when the user or the host or devices are connected as well. So we'll move to the automated response. The ability to respond to threats as they identified is essential to maintaining a secure environment. Compromised devices, sorry. So compromised devices or intentional malicious behavior can cost millions, damage or destroy critical data, and they can be very time consuming or difficult to track down. So Fortinet supplies automated threat response through integration with best breed of security tools, complete end-to-end visibility and control at the point of connection. So the identified threats can be mitigated almost instantly, keeping damaging software and bad actors well contained. So one of the most powerful aspects of Fortinet is its ability to bridge the gap between the SOC and the NOC departments by combining the detailed security event information with current and historical contextual of who is connecting to your network, what is connecting, where the user is connecting from, and the details of when that user or device is connecting from. And his ability to identify the threat and contain it is at the point of connection within seconds, and it helps to prevent the spread of potentially malicious software and put an immediate end to the malicious behavior as well. So we'll talk about how Fortinet does this, the containment of lateral threats at the edge. So here on this page is a simple example of how Fortinet can mitigate potential security threats. So let's say a user brings an infected laptop to a work. This will be demonstrated later. A user brings a infected laptop to work, and he or she connects the laptop or the device to your network. So traffic is generated by the infected laptop, and also it triggers it. It is triggered the alarm or the alert is being triggered by maybe your firewall that you put in place, and that's because your firewall is being integrated with Fortinet. So the firewall can send security event information to Fortinet. So now the Fortinet can now then notify the security team and the network team with an alert information, as well as detailed contextual of who connected and what actually connected and where the user is connecting from. Once Fortinet sends once the firewall sends the security details to FortiNAC, because it's been integrated, FortiNAC can show the contextual information of that user and be able to send it to security information. And if a policy has been set up by FortiNAC to quarantine the device, to disable the host, FortiNAC will be able to do that in a matter of seconds, and the laptop, the system will be quarantined, and until it is remediation is being done by the end users or by the IT team. So FortiNAC also integrates with other security solutions like the SIEM, Splunk. We have firewall device, SIEM, the ServiceNow, Jira services, ticketing services, and all that. You can integrate FortiNAC with this team, and they can be able to work together to form a platform for your ecosystem. So talking about the security rules, this is also part of the control aspect of the FortiNAC. The security rules are created by FortiNAC administrator based on the desire, the output desire that is needed at that point in time. Then these security rules can be customized to match specific security alert instances, or be more generalized to match a larger range of security alerts. The security rule consists of a trigger, a profile, and can also include an action based on the workflow in the event center. So a security trigger as well can contain one or more security filters. So there are some security featuring specification that we put in place to be able to take some level of action to be able to restrict users, put the users in the appropriate security groups for them to have a level of access to the environment as well. So we have the user host profile, which can be added to security rule in order to handle the same security alert. One other thing is that FortiNAC can integrate with third-party authentication server, like I mentioned earlier, both LDAP, ADAP server, radius server, and other. Another thing is that FortiNAC can also serve as a radius server to your users. So if you don't have maybe a server in place, FortiNAC can serve as a server in itself to ensure that users authenticating can authenticate it against the database on FortiNAC, and there won't be any unknown users or untrusted users without connecting to your environment. All this will be demonstrated. I have a demonstration page that I'll bring up now. But before I go there, I want to also talk about the licensing and deployment example. So the licensing module, FortiNAC comes in majorly in two form factor, which is a physical appliance. So you can get FortiNAC as a physical device, or you can get FortiNAC as a VM. So in getting this, and the three capabilities can also be achieved in both two form factors. So we have three levels of licensing that you can get when you get a FortiNAC device. We have the base license, we have the plus license, we have the pro license. The base license is just for detection and control of systems. So so when you have the base license, you can enjoy having visibility across your ecosystem, integrate all your third-party devices to FortiNAC. Then you can set a level of control for those devices, users, and hosts as well. That's for the base license. The plus license goes further into having a plus of adding the BYOD guests and contractors onboarding license to it. So in case of you have like staffs that are bringing their system to the workplace, and you want to have a level of control for them. You want them to be onboarding themselves, or you want to dedicate a sponsor so that their traffic the activity can be monitored. So we want to get the Plus license, Plus FortiNAC license, which supports the guest and contractor onboarding system. Then the Pro license covers everything